In today's video, I would like to introduce a very nice problem of Indian Mathematical Olympiad edition 2008. Here is the following setup. Find all triples p, x and y of natural numbers with prime p such that we have this following equation: p to the x equals y to the fourth plus number 4. Okay, up into this given information, we have the left hand side of this equation is a power of p, which means the right hand side of this equation must be a power of p as well. Okay, as we know that p prime must be even or odd, so we are going through two cases. So we are going to see when we have p as an even prime, and also we are going to see when we have p as an odd prime. So I would be recommend to give the try to this problem pre getting to the solution. So go ahead, pause this video when we come back to see the full solution. Okay, now let's go through this one. We have this following equation: p to the x equals y to the fourth plus number 4. Okay, now we are going to discuss the case when we have p as an even prime. So if p equals 2 as an even prime, I'm simply going to insert this value of p into the original equation to see what's the expression. So we'll have 2 to the x equals y to the fourth plus number 4. Okay, so it's clearly here, since we have y as a natural number, which means this term must be strictly superior than 4. Okay, which equals 2 to the 2. This one is telling us, this one implies x must be strictly superior than 1. Okay, on the other side, since the left hand side of this equation is even, which means the right hand side of this equation must be even as well. So since number 4 is even, which means y to the fourth must be even, which means y must be even. In the other words, y must be written on this form: y to equals 2m, like this. Okay, then I'm going to take this value of y and insert it into this equation and solve this equation. Okay, so we'll have 2 to the x equals y to the fourth, which is 2 to the fourth is multiplied by m to the fourth plus number 4. Okay, since we have x is strictly superior than 1, I'm going to divide both sides by number 4. Okay, so this one will have 2 to the x minus 2. This one 2 to the fourth, by dividing this term by number 2 to the 2 is giving us 2 to the 2 is multiplied by m to the fourth plus number 1. Okay, now since the left hand side of this equation is even, but the right hand side of this equation is odd. Okay, because this term is even plus number 1 becomes odd, which is contradiction, which is impossible. This one is telling us p must be odd. Now we are going to solve our problem on this one. So when we have p as an odd prime, I'm going to start solving this equation. So we'll have p to the x equals y to the fourth plus number 4. I'm going to factor out this one. If you take a look at this term is almost to get a quinary square here, but we have only one short term. So the first term is the same as y squared to the square plus something plus number 4. Okay, we're missing this term 4y squared, like this, because this one becomes a quinary square. Since we add this number, we must subtract it as well, so which means minus 4y squared. So this one will be written on this form: y squared plus number 2 quinary square minus 4y squared. So also this one is written on the form of the difference of two squares, so I'm going to transfer this one into the product. Okay, so we'll have p to the x equals y squared. By rearranging these terms, we'll have y squared minus 2y plus number 2 factor y squared plus 2y plus number 2. Okay, so I have ended with a nice expression. So the nice thing here, the left hand side of this equation is a power of p, which means the right hand side of this equation must be a power of p as well. Okay, we are going to translate this one into a equation system of y squared plus 2y plus number 2 equals p to the j, and y square minus 2y plus number 2 equals p to the I, where is j is strictly superior than I. Okay, it's very clear here. I'm going to solve this equation by taking this equation minus this equation. If I'm going to do so, this equation, so many things will be cancelled out here. So y square will be cancelled out, this number 2 will be cancelled out. I will be left with 2y minus 2y, which is 4y. Okay, so this one I will have 4y, this one I will have p to the j minus p to the I. Since p to the I is smaller than p to the j, I'm going to take this p to the I as a common factor. I will have p to the I factor p to the j minus I minus number 1. Okay, so I have ended with this expression. Now I'm going to take this found fact at the top and continue solving our equation. Previously we were solving this equation and came up with this nice expression. Our goal, we are going to calculate I. Okay, what's the I value? Before we start processing with this proof, we are going to collect all necessary information. Okay, if we are going back to the original equation, so we have the left hand side of this equation is a odd prime, which means the right hand side of this equation is a odd as well. Since number 4 is a even, which means y to the 4th is a odd, which means y is a odd. So I know the parity of y is a odd. This one is going to help us a lot, because if we go back to this product, we have 4y is a even, and these two terms, we have this number is a even, because we have this one is a odd minus number 1 becomes even. This one is a odd because it's a odd prime. Since this term 4y is bigger than p to the I, this one is telling us p to the I is divide 4y. This implies since number 4 is a even, which means since number 4 is a even, which means p to the I not divide 4. This one is telling us p to the I must be divide y. Now what's this one is telling us? This one is telling us y equals m is multiplied by p to the I, where is the m is a sum of natural numbers. According to the divisibility statement, we have proportionality between this number y and this odd prime. Okay, the second information, we know x equals j plus I, because this is the exponent x, p to the x. We know this term is a p to the I. We know this term p to the j. So which means the exponent, which means p to the x equals p to the I is multiplied by p to the j, which equals p to the a plus j. So one is telling us x equals j I plus j. Okay, we are going to take also this second information. Moreover, we know j is strictly superior than I. Okay, this one is telling us j equals I plus c, where is a c is a sum natural numbers. Okay, and also I'm going to keep this third information. I'm going to take all this found fact and insert them into the original equation to see what's the expression. Okay, so we'll have p to the x, it will be replaced with p to the j plus I. Y to the 4th will be replaced with this value, with m is multiplied by p to the I all to the 4th plus number 4. Okay, so by replacing j with this fact I plus c, I will have p to the I plus c plus I, which equals p to the 2i plus c equals m to the 4th is multiplied by p to the 4th I plus number 4. So I'm going to leave number 4 on the right hand side of this equation and move over this term to the left hand side of this equation. P to the I plus C minus m to the fourth is multiplied by p to the fourth for I equals number 4. Since this difference is a positive, which means this term is smaller than this term, which means I'm going to take p to the 4i as a common factor. I will have p to the 4i factor. This one, it was multiplied by p to the c minus 2i, okay, minus m to the fourth equals number 4, okay. This one is a positive, this one must be positive as well, which means this term is bigger than this term. This number 4 equals number 1 is multiplied by number 4, okay. So the most important information that I'm going to extract from this equation, we have this term p to the 4i is an odd prime, okay, which means is going to take the odd term from the right hand side of this equation, which is number 1. This number 4 must be equals to this one, so this one is telling us p to the 4i equals number 1. Since p is an odd prime, which means p is super equal to 3, which means the exponent is 0. This one is telling us I equals 0, okay. Now we found the value of I, which equals to 0. Now by taking this found fact and insert it into this equation to see what's the final expression. This one is telling us 4y p to the I equals 1. So this one will have p to the j minus 0, which is 0, minus number 1 equivalent. By taking this minus 1 to the left hand side of this equation, I will have, which is 4y plus number 1 equals p to the j. I have ended with this nice expression. Now I'm going to bring this one at the top and continue solving our equation. Previously we have proven I equals 0 and we came up with this expression. Now I'm simply going to solve this equation. Found 4y plus 1 equals p to the j. P to the j equals to this quantity, which means I will have 4y plus number 1 equals to this term, y squared plus 2y plus number 2, okay. This number 2 cancelled down to the number 1 because this number 1 will be cancelled out. So which means I'm going to move over this 4y to the right hand side of this equation. I will have y squared 2y minus 4y, which is minus 2y plus number 1 equals 0, okay. This one equivalent y minus 1 quantity squared equals 0, okay. So this one is telling us y equals 1, okay. Now I found the value of y equals 1, so now it's more simple to find x and p. I'm simply going to replace this found fact into the original equation to find x and p. So we'll have p to the x equals y to the 4, which is 1 to the 4th plus number 4, which is 1 plus 4, which is equals 5. Since we have p to the x equals 5, which means the exponent equals 1, okay. So this one is telling us x equals 1 and p equals 5. Now we have determined the triple p equals 5 and x equals 1 and y equals 1, okay. So I have done with this problem. If you have any question or suggestion, just put it in the comment section below. Don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.